In this lesson, we are going to learn the basics of natural language processing, also known as NLP. In cybersecurity, we are often faced with data that is in text form. For example, Python scripts, JavaScripts, PowerShell scripts, all forms of logs like Windows events logs, network logs, etc., and emails. To apply machine learning to this sort of data, we have to convert the text into something numerical so that we can actually apply statistical algorithms and machine learning to learn. The most basic NLP technique is probably bag of words. In bag of words, you simply count the number of times each word appears and use that count as the element in your vector. Notice that you don't care about the order, you don't care about whether one word was preceded by another. All you care about is how many times. So as an example, if I have the sentence, the quick brown fox jumps over the lazy dog, when I convert it into a vector, you'll see that the word the appears twice and every other word appeared once, and therefore I get the following vector. When I have a larger collection of words, I'll have a larger vector, and of course I'll want to keep track of which element corresponds to which word. A more sophisticated NLP technique is TF-IDF. TF-IDF stands for Term Frequency Inverse Document Frequency. To understand what this means, let us understand what TF-IDF does. So you start with a collection of text documents. This is known as a corpus. Each document will be transformed into a vector, which is our original goal. And the way we do it is as follows. The entries of the vector will be weights, and pretty much every word gets a weight. The weight of the word is equal to the number of times it appears in that document. This is TF, term frequency, divided by the number of documents that it's in. This is inverse document frequency, IDF. The consequence is that when a word occurs a lot in a specific document, it gets a large weight. Presumably it's important. However, if this word is extremely common in general, then it will be discounted. This is the IDF. One illustration would be stop words, or words that don't have much meaning but occur often, that will be discounted by IDF. So words like the usually don't mean much, but they occur all over the place. The effect of IDF is to discount this, as opposed to bag of words where such a word appears so much and is apparently important. Let's see how to use some of these NLP techniques on actual data. First thing I'm going to do is load the 20 newsgroups dataset. Each data point is a text, and the target is an integer representing the class to which it belongs. I'm going to load the TF-IDF vectorizer and transform my dataset. The resulting transformed data is now a sparse matrix. Next, I'm going to train a classifier, in this case XGBoost, on the transformed dataset. And then I'm going to score it. And you can see that thanks to the usage of TF-IDF, we're able to build a classifier on this data which consists of text. Next up, we're going to discuss how to use anomaly detection using isolation forest. See you then.